Okay, so in this one, I'm going to look at a section of the work known as word problems. Okay, so this is a section that is found in grade 9 as well as grade 10. Okay, so both grade 9s as well as grade 10s, they can watch this video because it's going to assist both of them. Okay, so in grade 11 is just a continuation of this section of the work where now you look at word problems that can result in quadratic equations as well as some advanced simultaneous equations there. Okay, but for this one, it's a grade 9 and 10 a word problem section whereby we are only going to focus, it's going to result in linear equations. We're not going to have anything to do with quadratic equations here. Okay, so the thing with word problems, most students, they struggle with word problems because word problems, they require you to be able to translate. Okay, you must be able to translate words, into equations, into mathematical equations or mathematical language. Okay, let's just say mathematical language. Okay, that's very important. You must be able to translate words into equations or the mathematical language. That's where the issue is. Okay, so you must be sorry about that. You must understand the problem clearly in such a way that you can be able to translate it into equations or mathematical language. Okay, so let's look at the approach. I said here it's how do we actually approach these word problems, the approach to these word problems. The first thing is you must read the problem statement. Okay, you must understand the problem statement. So you must read the problem statement and make sure that you understand the problem clearly. Okay, you must understand the scenario that is presented to you. Okay, when you read it, you must be able to understand the scenario that is presented to you so that you can be able to translate that scenario into mathematics. Okay, then you must be able to identify the unknown quantities in the problem. You must be able to identify what is one thing that I don't know. Okay, you must be able to identify the unknown or unknowns in the problem statement. Okay, so the problem statement itself, you must be able to pick out information that you don't know. Okay, and then you must let the unknown quantity be x. Okay, if there is another unknown quantity in the problem statement, express it in terms of what? Of the first unknown or x. Okay, that's another thing you must be able to do. Then you must then set up an algebraic equation and then solve. Okay, now the keywords, some of the keywords that you're going to get in this, it's words such as will be. When you look at age problems, okay, in the age problem specifically, you will see words like keywords such as will be, will, is, and was. These kind of words, these keywords here, you're going to see most of these keywords. Okay, let me just say these are key words. These keywords in mathematics, they are indicated by an equal sign. Okay, equal sign. The moment you see these words, will be, is, was, this is an equal sign in mathematics, especially when you look at the age problems. Okay, they represent an equal sign in mathematics. So that's what I mean when I say you must be able to translate English, the problems, we must be able to translate English into mathematical language or mathematics. Okay, and then I said something very important here. You must remember to answer the question after you solve the equation. Okay, now let's have a look at the practical problems that I have here. Okay, whereby we're going to apply this technique of solving problems to actual problems here. Okay, example 1, which is an example of age. Okay, we're looking at age problems here. So let's read here. Let's look at this one. They say here, ladies and gentlemen, the sum of the ages. Okay, let me just use yellow to highlight. The sum of the ages of a brother and a sister is 24. Okay, the sum, it's a keyword. Highlight it. Okay, it's a keyword. The sum of the ages of a brother and sister is 24. Okay, 3 years from now, rather, not 3 years ago, but 3 years from now. 3 years from now, the brother will be twice, will be twice as old as his sister will be then. Okay, determine their present ages. Okay, note that the brother is the older one. So the brother is the older one according to this problem statement for 4 marks. Now, when you get something like this, an age problem, it's very important that you draw a table. Make sure that you draw a table, ladies and gentlemen. Draw a table. Okay, draw a table so that you can be able to represent this scenario clearly, okay, because this scenario, when you have a table, the scenario is going to be represented clearly there. Okay, so you're going to draw a table, and then in the table, what we put in the table, we put in the two people that are involved. We have got a brother and a sister. Okay, so we have a brother and a sister, so I'm just going to put them there, sister as well as a brother. These are the two people that are involved in this problem here, a brother. Okay, then I'm going to say now. I'm going to put the now scenario now, and then I'm going to put 3 years from now. 3 years from now. 3 years from now scenario. Okay, then according to our approach to this is that we understood the problem. Okay, our problem now we understand is that the sum of the ages of the brother and sister now, when we add their ages now, it's 24. 3 years from now, 3 years from now, then we know we are being told that the brother's age will be twice as old. The brother will be twice as old as the sister will be then. Okay, so now the thing is we must identify what is one thing that we don't know. What is one thing that we don't know? We can see that we don't know the sister's age now and the brother's age now. So because we don't know their ages now, we are just going to say, okay, now if let's say we put X, we're going to pick between the brother and sister because we both don't know their age. We don't know their age, both of them. We don't know their age. Okay, for both of them, we don't know how old they are now. So you can pick between a sister and a brother, which one you want to let X to be. Okay, you can let anyone between the two to be X. So if the sister's age is X now, let's say we are assuming we are putting X for the sister's age now. Now, the sister, we are saying the sister now it's X. Okay, then now, because we know that the sum of their ages now is 24. The sum of their ages now is what? Is 24. If the sister is X now, then the problem statement, the approach told us that we must then express the what? The age of the second person now in terms of the first person. So because we know that the sum of their ages is 24, then automatically if the sister is X, the brother must then be the 24 minus the sister's age. Because when we add their ages, we get what? We get 24. So that's what we do. Okay, these are their ages expressed in terms of X now. Okay, then now. Then we ask ourselves, if the sister is X years now, what will be the sister's age 3 years from now? If the sister's age is X now, what will be the sister's age 3 years from now? Now, we should agree with me that if the sister is X now, then the sister's age 3 years from now is going to be X increased with 3. That is the sister's age 3 years from now. Okay, the sister is just going to increase her age by 3. And you should also agree with me that also the brother is going to just be 24, the current age. The brother is going to be the current age added with 3. Now 24 minus X increased by 3. Now you should agree with me that this simplified is just 27 minus X. So I'm just going to say 27 minus X here. You should agree with me that those will be the ages now, 27 minus X, because you just take the current age now. Because you should agree with me that if you are 10 years old now, 3 years from now you'll be 10 plus 3, which means you'll be 13 years old. Okay, that's what I did here. So these are their ages expressed in terms of X from the table. Then you set up the equation. Now you go. The first, always I usually say the first bullet point, the first statement, it's used to create what? It's used to create a table. It's used to draw a table. Then the second statement is the one that you use to form a what? An equation. Okay, 3 years from now, the brother will be. So 3 years from now, you go and focus on the 3 years from now column. You go and focus on the 3 years from now table, the column, this one. You ignore the now column now. You just ignore the now column. So you ask yourself, they say 3 years from now, the brother. So you write the scenario down. Okay, you just write the scenario down. So let me just use this piece. So you're going to say, they say 3 years from now, the brother. You just write it down in ways like this. You say brother. Then they said brother will be. So will be, you just put equal sign. That's an equal sign in maths from the keyword. So brother will be twice as old as the sister. So brother will be 2 times the sister. Okay, from the problem statement. And then you ask yourself, which column are we in? We are in the 3 years from now column. So you just replace with those ages, the ages in terms of X here. So what is the brother's age in terms of X 3 years from now? You're focusing on the 3 years from now column. It's 27 minus X. So you're just going to say 27 minus X, which is the brother's age 3 years from now. Okay, 3 years from now, the brother's age is 27 minus X. So you're just going to say 27 minus X equals to 2 times, these 2 times, the sister's age 3 years from now, and the 3 years from now column, which is X plus 3. Then this is our equation. We have set up an equation there. The only thing is to solve. Let's solve. So we say therefore 27 minus x equals to 2x plus 6 when you distribute there. Then you can see that 27 minus 6 is 21 is the same as 3x, and then divide both sides by 3, and then you should see that your x is equals to 7. Okay, so your x is 7. Now what is x according to this? Our x is the sister's age, so that means that automatically the sister's age is 7. The sister is 7 years old, and then the brother 24 minus 7. The brother is 24 minus 7. The brother is 24 minus 7 is going to be 24 minus 7, I think it's 17. Yes, and remember that the brother according to the statement is the older one, so the x, the smaller one, has to be what? The sister. The bigger one has to be the brother. The brother is the older one rather. Okay, sorry about that. The older one is the brother. So 24 minus 7, I think it's 17. So the sister's age is 7, and then the brother is currently 17 years old. Okay, that's how you solve it. Okay, that's how you solve it. That's how you represent these scenarios using words. And if you have a look at this, 3 years from now, the sister is going to be 10 years old, because it's going to be 7 plus 3. So the sister will be 10, the brother will be 17 plus 3, which is 20. And you can see that the brother is 3 years from now, the brother will be twice as old as the sister, because 20 divided by 10 is 2. So the brother 3 years from now, you can see it makes sense that our answers are actually correct, because the brother will be twice as old as the sister. Okay. Very interesting. Let's check the second one. Example 2. Okay, example 2. So with example 2 here, let me just erase here so that we can draw a table. It's very important that you draw a table and show that you understand the sum. Okay, draw a table to show that you actually understand what's going on. You draw a table every time you get a problem like this. Okay, so I'm just going to, in fact, I'm going to do the next video now so that I can do this problem. Let me just stop this one, and then in the next video I'm just continuing here. Okay, thank you.